Number 10 is kind of an interesting problem because we have two sets of data, and it says that one of these can be best modeled by a linear function, the other shows data that can be best modeled by a quadratic function. So we've done some problems like this before where we have data and we have different regressions and they ask like which one's better. So if you run a linear regression on the first set of data, then you should get y is equal to 10x plus 8, and we have an r value of 0.993, so that's pretty good. Quadratic, you should get y is equal to 1x squared plus 6x plus 10, and the r squared value, because again, quadratic regressions don't have r values, they just have r squared values. This is equal to 1. So if you graph both of them, let's see if I can use different colors here. Let's do, I have so many choices. Let's do purple. And the data was like this. And then the linear kind of look like that. So they're both pretty good, but the quadratic one is perfect. So the quadratic is going to be the better one here. Looking at the second set of data, the linear is going to be y is equal to 7x plus 10, and you'll find that the r value is 1, so that's perfect. The quadratic is going to be y is equal to 0x squared plus 7x plus 10, and here the r squared is equal to 1 as well. So this is kind of interesting. If you graph it, you'll notice that these are actually the same thing, which should make sense because the 0, if you just take away the 0x squared, we get 7x plus 10, which is the exact same thing as the linear one. So it's actually the exact same model. So when they ask what's better, I mean, it's technically linear. So they're the same, but the answer is linear because the quadratic one is like effectively acting like a linear function. So anything that's linear, if your quadratic function just has a 0 for an x squared, it can also model it with a linear function. So it's kind of nice about the quadratic models that it can imitate a linear function. But again, for our answer, it's technically a linear function, not a quadratic.